Hey, second graders, guess what? Today we're doing a screencastify so you can see a really cool website that you're going to be using. But first, I want to tell you today is Module 8, Lesson 7, and I have my tangrams here from yesterday. So I was playing around with the two small triangles, and I took them and I put them together, and then I made just one new triangle from the two small triangles, okay? Now, this triangle, though, is made up of two parts, and these two parts are equal, and I can prove it because I can lay one on top of the other, and you can't see the one underneath sticking out on top of the one on top. So they are the same size and same shape. So I know they're equal. So what I was thinking is if I have two equal parts with this triangle, then we can call these, each part is called a half, right? And so I have halves here. Halves. Remember, halves is one of those that when it's half, it's H-A-L-F, and then when you make it plural, like more than one, it's H-A-L-V-E-S. So I have two halves here, okay? Now, the reason that I wanted to show you my screen and Screencastify is because we are going to use pattern blocks today to create some composite shapes, just like we did yesterday with tangrams. And we're going to see if we have halves or maybe even if we have some other fractions. So the first pattern block I want you to see me explore today is this hexagon. So I'm going to get this yellow hexagon and put it right here in the middle. Now this yellow hexagon has how many sides? Let's count them. 1, 2, 3, 4, 5, 6. Correct. It's got 6 sides, so it's a hexagon. This is a regular hexagon, which you'll learn more about those next year because all the sides are equal and all the angles are the same size also. So it's a regular hexagon, but we already learned earlier that a hexagon doesn't have to look like this. We're used to seeing it look like this, but it doesn't have to. Any 6-sided polygon is a hexagon, even if it looks like a house or something else. So when I look at this hexagon and I come up here and I'm going to get a trapezoid. Now, yesterday, I think I misspoke because I think I told you yesterday that a parallelogram can also be considered a trapezoid. Remember, this is a parallelogram. And the reason I said that, or the reason I thought that, was because I've seen it. I don't know why I thought this. I've seen it somewhere before that if you have at least one pair of parallel sides, that you're a trapezoid. And this here has just one pair of parallel sides. The top and the bottom are parallel. But these two here are not parallel. In fact, if you draw this line up like this, you're going to get the point of like a triangle, and they're going to cross when you get up here. Those are not parallel. So these sides, so this only has one pair of parallel sides. So this is a trapezoid. It can't be a parallelogram because it only has one pair of parallel sides. But this has two pairs of parallel sides. So we call this one a parallelogram. And I don't want to call this a trapezoid anymore because I'm still really getting confused here. Some sources I'm looking at would say that because it has at least one. Others are saying that no, a trapezoid only has one pair of parallel sides. So from going forward, parallelogram, trapezoid on the screen. Okay, so here's my trapezoid, right? Back to the point I was trying to make. I can rotate it by using these arrows like this, okay? And what I was thinking was if I take this, I'm going to have to get it rotated just right to show you, but if I put it here, I think that did it. It looks pretty close to the red trapezoid is 1/2 of the yellow hexagon. So I'm going to get another red trapezoid here. Let's make sure we get it turned just so. Look at that. So see that technically I'm not supposed to have that gap there, but if I had pattern blocks out on my desk in the classroom, I wouldn't see that. Okay, 2 red trapezoids make 1 yellow hexagon. So here is an example again of halves. They have to be equal. They must be equal to be able to call them halves. If they're not equal, you cannot call it half. You might have 2 parts for sure, but they're not halves because they're not the same size. Okay, so let's get another polygon down now. This time I'm gonna go over here, and when I click start over, it starts over my screen. So now I have a clean one. Let's just get the red trapezoid now. All right, so there's the red trapezoid. And what I was thinking is there a, can you cover this trapezoid using 3 smaller polygons? Now they have to be the same. And so you might have tried to use this tan rhombus. No. Can you do it with the square? No. We know it can't be the hexagon. So what you're going to find is if you want to cover it with 3, you're going to use the green triangle. So let's get it on here just right. Look at that. There's one of them. We need to come over here and get another one, and we got to turn it. We got to rotate it to, I think got to rotate it just a smidge more. Yep. Just get it just right, and then get a third one here. Now, this one does have equal pieces, right? But this is cut into 3 equal pieces, not halves. Halves would be 2. This is 3. And so we would call this thirds. Think of like 3rd grade where you guys are all going next year. Thirds. Thirds means 3 equal pieces. Now, if we had cut it into 3 pieces and they weren't all the same, they weren't all equal, we couldn't call them thirds. We'd have 3 pieces or 3 parts, but it wouldn't be thirds. Okay? Now, we've covered that whole trapezoid there. Let's see. What I was thinking, oh, there's another way to do this too. Let's just start over. If we get this guy here, the yellow hexagon, we can cover this yellow hexagon with thirds also. So we could take our blue rhombus. Now, look at that. There's one part. I'm not going to do all of this for you, but I bet those of you that are good at games where you can rotate pieces and shapes, you can see how this all kind of starts to come together here, okay? But so we would have 3 of those blue rhombuses would make one yellow hexagon. That would also show you thirds, okay? Finally, I don't know that I have what I need to show you here. I was going to try to show you fourths, but I don't think I can do that here. In fact, I know I can't do that here with these pattern blocks. The square right here, I could cut it into fourths if I folded it in half here and then came this way. Or I could do a half and then I could make 4 long skinny lines. Let me see, where is I guess I could show you with my square, whatchamacallit? It's my tangram. I could fold it like this, and then if I fold it like this, oh, it's hard to fold. This guy's tiny. Then if I open it back up, I have 4 equal pieces. As long as the pieces are the same, you have fourths, the same amount. And you spell that F-O-U-R like 4, and then fourths. All right, so today we've talked about halves, thirds, and fourths, and how to show some of those with pattern blocks. When you get to your problem set today, A, B, and C, and D are going to have you using your tangram pieces, and then E and F. But then when you get on to number 2, they're going to try to trick you because they're going to ask you to circle the shapes that show halves. Now, we talked about this. Halves means you have to have equal pieces. Doesn't just mean 2 pieces, because I know that if I was going to share, if this was something that I wanted to have a lot of, and I tore it like this and said, okay, here's your half, and here's my half, you all would say, whoa, that's not halves. those pieces aren't equal. So they're going to show you some shapes that are divided, but you got to look closely because they're not equal, okay? So you're going to be circling the shapes that show halves, and then it's going to have you, number 3 wants you to show how 3 triangle pattern blocks can form a trapezoid and draw it. You can use this here to do it, and then I want you to draw it on the paper, okay? Then it's going to ask you some questions about thirds, and then it's going to ask you some questions about fourths, okay? Same rules apply. You do not have thirds and fourths.
Mom, these are not
That's
equal.
right. They're not equal. Does one have more than the other?
Yeah.
So do you?
This one has more.
That one has more. So do you have halves?
This one has more.
So
That one does.
do you have halves? No, because they're not equal. All right. See, my kindergartner knows. All right, guys. So I think you have everything you need today to do this assignment. Have fun with the pattern blocks. Bye.
Mommy, can we sing?
Maybe bye. I can't even hang up. Hang on, Sophie. Where's my screen castify?